Chapter 5, Section 2 continues on with ionic bonds. Ionic bonds are just a force of attraction between ions of opposite charges, so electrons being transferred from the positive ion to the negative ion. Here the diagram is showing a sodium electron being transferred to a chlorine ion in order to form sodium chloride. Some terms in this section, coulombic force, which is an attraction or repulsion between two charged objects. So you could be talking about a positive and negative charge being attracted to each other, or negatives repelling or positives repelling each other, and those are still referred to as coulombic forces. Another term mentioned here are halides, and halides are just salts that have a halogen anion in them. So any ionic compound that has one of the halogens, chlorine, bromine, iodine, astatine, all of those are referred to as halides. So for instance, sodium chloride or potassium bromide, these are both halides. And just kind of a side note, salts are referred to as any ionic compound, so we're not just talking about regular sodium chloride or table salt. It's any sort of ionic compound. It's just a very general term. A crystal lattice is going to be a repetitive geometric arrangement of atoms, and this is how ionic compounds are combined. And the unit cell is going to be the smallest repeating unit within that crystal. So, for instance, in this crystal here, you're going to have a sodium ion surrounded by chlorine ions, and each chlorine ion surrounded by sodium ions. So it forms a very strong, rigid structure. The lattice energy is going to be the energy that gets released when atoms, ions, or molecules come together to form that crystal lattice structure. So that's really the key to forming ionic bonds. And finally, there are some properties of binary ionic compounds. One is that they're going to be very hard and brittle, and that comes from that crystal lattice structure. If you had a giant salt crystal that you took a sledgehammer to, chances are you are not going to dent that salt crystal. If it broke, it would shatter, or a chunk of it would break off, but you probably would not dent it. It is a very brittle structure. The next thing is that they melt and boil at very high temperatures. All those bonds that go into forming that crystal will need to be broken in order to melt or boil those substances. So it takes a lot of energy to do that, which means that the melting and boiling points are going to be very high. Dissolving also takes a very long time because you have to strip layer by layer off of those crystals until you can get to the center. And finally, in the solid form, ionic compounds generally are not going to conduct electricity. Their electrons are pretty much stuck in place within that crystal lattice. But once you dissolve those solids into water and make an aqueous solution, those ions are able to split apart and the electrons are able to move, and that will help to conduct electric current.